Good evening, I am Mr. Ish. You are looking here at a video on inverse of functions. Not a difficult subject because even as 12th graders or 11th graders or those students entering college, they're expected to know this inverse of functions. But we will be talking and looking at this subject in a very general sense. If there are any conditions or exceptions that apply, we won't look at them because we'll be looking at this in a very general manner. If you have a specific function, and let's use fxn for a function, you can easily determine its inverse. If that represents a function in terms of notation, the inverse is this. An inverse of a function is an opposite of a function. You can easily determine an inverse of a function if over the entire domain of that original function, the entire domain, whatever that domain might be, you have a one-to-one relationship between x and y values. What does that mean? It means that your original function passes the horizontal line test. I'm using this little check mark that the original function right here, it fulfills the horizontal line test. What is a horizontal line test? If you were to draw two functions, and let's look at that. You have one function which looks like a straight line. You were to draw a horizontal line through it. Just like the vertical line, the horizontal line must pass through that original function at only one point. If it passes through that original function at only one point, it passes the horizontal line test, and it's a successful horizontal line test. We can draw a little smiley face. If the original function has appearance such as this, and now you're drawing horizontal lines, you know you're crossing that original function at 2 points, or sometimes at more than 2 points, then the horizontal line test fails, and we are failing that. So the original function does not have an inverse. But of course, exceptions and conditions apply in these instances such as this, but we're not looking at them because we're talking about inverse of functions in a general sense, something that you would have to know for a standardized exam and nothing more difficult than that. Again, remember, a function has an inverse if over the entire domain of that original function there is a one-to-one correspondence between x and y value, and that can be graphically represented as a horizontal line test. It can also be represented such as this. You have no instance where you have a plus and minus x giving rise to y, where you have two separate x values or multiple x values giving rise to the same y value. In that instance, you don't have a one-to-one, and in instances such as this, the horizontal line test will fail. We will look at two questions and bring this concept home. Our first question is this with multiple parts, but it won't be hard. Which function would have an inverse function over its entire domain? That is, if you were to draw that function, which one would have one-to-one correspondence over its entire domain for the x and the y values, such that you could easily represent a function and convert it into its inverse. Let's look here at e to the x, function e to the x. If you are good with graphing, or the various graphing forms, you know, an exponential function looks something like this. If you were to draw a horizontal line through this, it'll always cross at one point. So this function checks and it succeeds the horizontal line test, and this would be one of those functions which would have an inverse over its entire domain. Sine x. The sine x has a domain minus infinity, positive infinity, and it looks something like this. It's serpentine snake-like function, and you know trigonometric functions are commonly of this form. If you were to draw a horizontal line through it, and now you see it's crossing over multiple points, it fails the horizontal line test. So this function would not have an inverse over its entire domain. And remember, we're talking here in general sense. We're not talking about certain exceptions that could apply and could convert some of these no's into a yes. We're not looking at that. How about this? F of x is equal to absolute value of x. You know, a graph such as that looks like this. Vertex at the origin, and it is this. If you were to draw a horizontal line, it crosses at least 2 points, and it fails the horizontal line test. So this over its entire domain cannot have an inverse. What about x cubed, which is a cubic function? Well, you know the graph of that, or maybe you may not know the graph of that, but the graph of that is something like this, going to the origin. If you were to draw a bunch of horizontal lines, it would always cross at only one point. So this function succeeds the horizontal line test, and it will always have an inverse function over its entire domain. Alright, let's look at this second question right here, and we'll try to make this interesting. we have to calculate or find an inverse of the function that's given, and then we have to state the new domain of that inverse. Essentially what we're doing is we're taking a function and we're converting it into its inverse. And then for this inverse, we have to find the domain. If you have this function right here, an exponential function, we can even draw it out. If you were to put a 0 in place of x, you would have e to the power of 0, which is just a 1. 1 plus 1 would be a 2. You'd have a y-intercept of 0, 2. When you look at this function right here, this is my f of x. If you look at the domain over here, you know clearly it's minus infinity to positive infinity. Clearly, minus infinity to positive infinity. Now you have to find the inverse. How do you find the inverse? You know f of x is synonymous with y. You're saying y is equal to e to the x plus 1. To find the inverse of a function, when it is determined that it has an inverse, because this succeeds in the horizontal line test, any horizontal line will only cross at one point, you have to interconvert the y and the x. You mix them around. X is equal to e to the y plus 1. You see how you flipped the letters around, the variables. And now you have to solve for that new y. You take the 1 on the other side, x minus 1 is equal to e to the y. And now you have to solve for y. You have to use the properties of natural logs here. You bring this exponent right over here. ln x minus 1 is equal to y ln e, which is equal to a 1. And therefore y is equal to natural log x minus 1. And you can say y over here is your inverse. Inverse of your original function is equal to natural log x minus 1. That right there becomes the inverse of this original function. If this is my original function, e to the x plus 1, its inverse is natural log x minus 1. If you were to graph this out, I know we're becoming a little technical over here. You can get a good x-intercept here. You can just put a 1 over here, and you know if you put a 1 over here, you get natural log of 0, it wouldn't work. If you put a 2 over here, think about this as an x minus h in terms of the translation, which is in some sort of binding parentheses. When you have an x minus h, you're shifting to the right by h units. Here I have an x minus h, I'm shifting to the right by 1 unit. The normal natural log goes through 1, 0, and I've shifted it by 1 unit, so now I have an x-intercept of 2, 0, and now I know my new domain is 0 to infinity. My new domain over here would be 0, infinity. And that right there would be the end of this. We can make this even slightly more interesting by showing you a very interesting fact. If you look here at the original function, the domain was minus infinity to infinity. The range of this exponential function, always going from down to up, think about it, is 0 to infinity. The graph right here never goes below the x-axis, which is 0 in terms of y, but it goes up towards positive infinity. If you were to look at the range of this, you'll have minus infinity to infinity. The range of this new inverse would be minus infinity to infinity. And here's a very interesting fact. When you have an original function and its inverse, the domain and the range flip. The domain of this original function becomes the range of your new inverse function. The range of the original function becomes the domain of the new inverse function. You're seeing that, right? The domain over here is equivalent to the range over here. The range over here is equivalent to the domain over here. And original functions and their inverses have this domain and range flip. But again, if you have a function given and you have determined it succeeds in the horizontal line test, how do you find the inverse? You flip the letters around and you solve for the new y. And then always think in your back of your head, the original function, domain and range, and the new inverse function, domain and range, they'll be flipped around. And with that, let's end this video. Thank you for watching. Have a nice day.